Okay, so if we're asked to solve the polynomial equation x cubed minus 34x plus 12 equals 0, then there's a couple things we know from the start. First of all, there will be 3 complex zeros. They could be real, they could be imaginary, but there will be 3. They could be repeated. But we need a place to start, so let's begin with our possible rational zeros. And we know that we are looking at, in the numerator of our possible rational zeros, factors of the constant term, and in the denominator, the factors of the leading coefficient. So the factors of 12 are positive and negative 1, 2, 3, 4, 6, and 12. And the factors of our leading coefficient are 1. So basically we're looking at positive or negative 1, 2, 3, 4, 6, and 12. Okay. And it took me a couple tries, but eventually I found that negative 6 actually is a 0. And I verify that by using synthetic division. And I know that across the top, I'm going to have 1 for my x cubed, 1x cubed, minus, I need a 0 placeholder, don't I? Because I don't have an x squared term. So 1x cubed plus 0x squared minus 34x plus 12, positive 12. So I go through my process, drop the 1, I get negative 6 and add. Negative 6 times negative 6 is positive 36 and I add. And negative 6 times 2 is negative 12 and I add and get a remainder of 0, which verifies for me that negative 6 is in fact a 0 of this polynomial equation, is in fact a solution to this equation. Because negative 6 is a 0, I can now factor to x plus 6 times, and then I find the coefficients of my quadratic factor here, 1x squared minus 6x plus 2 equals 0. Okay, so I found one of my solutions. I need the other 2, and because this is not a quadratic that's going to factor, I'm going to have to use the quadratic formula. So x equals the opposite of negative 6 plus or minus the square root of negative 6 squared minus 4 times a times c all over 2 times a. So this is 6 plus or minus the square root of 36 minus 8 over 2. So this is 6 plus or minus the square root of 28 over 2. Now this is not in simplest form. 28 has a perfect square factor of 4. So 6 plus or minus the square root of 4 times 7 over 2, which is going to give me 6 plus or minus 2 square roots of 7 over 2. And now again, this is not in simplest form because 2 divides 6 and 2 divides 2. So I'm able to simplify further. So I could factor 2 out of my numerator, which would give me 3 plus or minus the square root of 7 all over 2. And then this common factor divides out. And I'm left with 3 plus or minus the square root of 7. So all 3 solutions include negative 6, 3 plus the square root of 7, and 3 minus the square root of 7. You have to simplify your quadratic solution, and you have to simplify it properly. Thanks.